Hey everyone, welcome back. Seriously, I am so pumped to have you here for day 6 of our ongoing explainer series on code review. Today, we are putting on our detective hats, ducking under the yellow tape, and looking at our code bases from a completely different perspective. We are talking about code smells. So get comfortable, lock in, and let's get this investigation started.
So let's just dive right in. What exactly is a code smell? Well, if you haven't heard the term before, you might be picturing something entirely different. But I want you to think of yourself as a detective, stepping onto a crime scene, which, in this case, is your software codebase. A code smell is not an outright bug, it's not some glaring fatal error that immediately crashes your system or throws a giant red warning across your screen. Nope, it is much more subtle. It's an underlying clue. It's a symptom that something deeper might have gone horribly wrong in the design or the logic of the code. You know how a strange scent in a room tells you something isn't quite right long before you actually see the problem? Well, a code smell does the exact same thing. It hints that your code might be rotting just beneath the surface and desperately needs a closer look. All right, here is our lineup of usual suspects. We have 6 specific, very common culprits that we need to learn to sniff out as effective code reviewers. We're looking for the long method, the God class, duplicate code, magic numbers, dead code, and feature envy. I want you to mentally lock in on these 6 terms right now. Memorize this lineup because these are the subtle little hints that your code is harboring hidden dangers. We're going to break these down one by one so you know exactly what to look for the next time you open up a file.
Okay, Section 1, Size and Redundancy. We're looking for clues related to unmanageable scale and repetitive errors.
Our very first suspect is the long method. And honestly, the name is incredibly literal here. It is simply a function or a method in your code that takes up way too much physical space. Why does this matter? Well, a method is supposed to do one specific thing and do it well. So when a single method just scrolls on and on, page after page, it usually means it's trying to do 5, 10, maybe 20 different things all at once. The danger here is total cognitive overload. When you, as a reviewer, have to read a massive, sprawling paragraph of logic, it becomes incredibly difficult to test, totally impossible to maintain, and an absolute nightmare to debug. It's a classic code smell that is practically screaming for the code to be broken down into smaller, bite-sized pieces.
Next, we step into the presence of something much larger, the God class. I want to slow down for a second and really unpack this one, because the name itself carries a ton of weight. The God class is this almighty, overly powerful, and highly dangerous entity sitting right inside your codebase. This is a class that has grown so large that it knows too much, and it does way too much. It hoards all the data, it controls the logic of a dozen different processes, and it bosses around far too many of the smaller classes. The incredibly dangerous thing about a God class is that it becomes a massive, fragile bottleneck for your entire system. If everything depends on this one almighty file, changing literally one small line of code can inadvertently break the entire universe of your software. You've got to catch this suspect early.
Now, let's contrast 2 completely different types of bloat: duplicate code versus magic numbers. Duplicate code is blatant, undeniable repetition. It's the classic copy and paste mistake. The exact same logic exists in 2, 3, maybe 20 different places. The problem? Well, if you ever need to fix a bug in that logic, you have to track down every single duplicated copy. It is a maintenance nightmare. Magic numbers, on the other hand, are totally unexplained hidden mysteries. A magic number is a hard-coded value. Like, imagine just seeing an isolated 42 or a random 86,400 sitting right in the middle of your code with absolutely no context. What does it mean? Why is it there? Without a descriptive variable name, it's a mystery that will completely baffle the next developer who has to read it. Both of these smells bloat and confuse your code, just in very different ways.
Moving right along to Section 2. Clutter and obscurity. This is where the code gets messy.
In this messy environment, we often stumble across dead code. And again, it's exactly what it sounds like, a useless, lifeless artifact just left behind. Think of it like digital cobwebs. Maybe it's a variable that gets declared but never actually read. Or maybe it's a method that is never called by anything else in the system. Or, and we see this a lot, an entire feature that was turned off years ago, but nobody ever bothered to delete the files. It doesn't execute, it doesn't add value to the user, it literally just sits there, cluttering up the place. And this matters because it actively distracts and confuses any developer trying to trace the living logic of the system. Bottom line, if it's dead, get it off the scene.
And our final suspect is feature envy. It's actually a psychological term, but here it's directly applied to software. It represents a scenario where one piece of code is overly fixated on another's data. Imagine a method in Class A that almost never uses its own data.
Instead, it constantly reaches over into Class B to ask for its data, process it, and then put it back. It is literally envious of the other class's properties. This is a massive clue for you as a reviewer. It usually means that the logic you're looking at is just living in the wrong place. If a method is obsessed with another class's data, that method should probably just be moved to live inside that other class. It's really all about putting things where they naturally belong.
All right, Section 3, time to practice. Let's take all this theory out into the real world.
Here is your assignment. Go review an open source project. You now know the 6 common smells, right? You know how to identify the long method, the God class, duplicate code, magic numbers, dead code, and feature envy. Honestly, the absolute best way to train your nose to actually catch these issues is to dive into a living, breathing codebase and conduct a review yourself. Open source projects are incredibly accessible, and they are the perfect practice grounds to start your investigation. Don't just read about this stuff, go look at real code written by real people and see how many of these 6 suspects you can spot.
So, as we wrap up this explainer, I want to leave you with one final provocative question. Which open source project will you review today? The suspects we just talked about, they are out there right now, hiding in plain sight in almost every major codebase on the planet. I challenge you to take what you've learned today, go out into the wild, pick a project you are actually passionate about, and start hunting for these code smells immediately. Get your hands dirty, train your eye. Thank you so much for joining me for this focused look at Day 6. Happy reviewing, and I will see you in the next explainer.